The title of this conversation is going to be, you don't need a custom model, you need an asset factory. And the idea is about going beyond using a single API, going beyond using a single model from Hugging Face. How can teams, organizations, or even in your own side projects, how can you bootstrap a system that's going to actually allow you to make valuable assets out of AI? So let's start with a use case. This is going to be a guiding use case throughout the presentation. We'll call it the photo tagger use case. And this is all going to be, the code is going to be all available. So don't need to go too into the weeds with that, because you can read all of the code. It's open source after the talk. So the use case is we have photos coming in. Let's say we have a batch of 10 photos or 100 photos. Doesn't really matter how many. We have some number of photos that come into our system every hour or every minute, every time that we hit a calendar event that we care about. The idea is that we want to build kind of this multi-object detection system where we have all these tags that are actual ground truth data from, in this case, we're using the Unsplash API, these kind of blue tags that we see. And we want to find what is the best system that we can build using a vision language model. What's the best system that we can build and kind of understand sort of the cost performance trade-off, and then tracking the different data model code that goes through this system as assets is what we mean when we say build an asset factory. So in the bottom left, kind of the first thing that we're indicating here is like, this isn't just random data files in an S3 bucket or something. We're already kind of leveling up the mindsets of each of these pieces of data that's flowing through our system belongs to a specific asset category, a specific type of data set. And what we're indicating here with this little snapshot from the Outerbounds UI is that you actually want to capture that early in the project. And we'll start to see how treating code data and models as assets kind of unlocks these systems benefits that we're pitching here with the LLM factory idea. So you can imagine, like, one of the first things you might do is you might take a model from Hugging Face. In this case, we have the Llama 3.2 11 billion parameter vision instruct model. It's hosted on Together AI, and we're kind of connecting that into our Outerbound system here. And it does okay. It gets 23% recall on this specific example. It gets, I guess, 4 out of the 9 things that it tagged are in the actual ground truth labels that we got from the Unsplash API. So to implement that kind of system, it's probably most people on this call, seasoned MLOps people, seasoned data scientists. It's not that hard to imagine. Kind of we have normal data workflow running this update photos workflow. That thing is going to be piping at some cadence, going to be piping data into this data assets bucket. We're registering that with Outerbounds in this case. But nonetheless, this is kind of similar to whatever system you use, Airflow, Kubeflow, Metaflow, whatever way you kind of run these data pipelines in your organization. This is basically just MLOps. We're pumping some data through the system, and then we are running batch inference in this case. Could be real-time inference, like whether these circles in the prompt models graph, whether those are Kubernetes pods or whether they're little nodes in some kind of lane graph situation, really doesn't matter in the context of this presentation. It's just some inference pipeline that produces responses. And in our case, the response is these image tags. So simple system, kind of like most people, this is like table stakes for having any kind of MLOps system. So one thing that is different in Gen AI is we often want many models to be served. So in addition to, we might want to experimentally test many models and different versions of those models. One reality of generative AI that's a bit distinct from machine learning classically is that at inference time in many of the most used products in Gen AI space, users are dynamically switching between models. So in this case, I was kind of having a chat in Cursor with Gemini model, and the Gemini model got to a point where it says, I'm unable to solve the problem. It kind of has this little existential crisis. I can't help you. Sorry, go talk to a human. Very unsatisfying user experience. And all I had to do is kind of switch to a Claude model. And then Claude immediately is like, oh, yeah, your TOML file's messed up. So this is a good example of one reason why you might want to go beyond having this single model in your system, whether it's your own thing that you fine-tuned or as a vendor API. So in the case of our use case, like what that looks like is let's just add some more rows. We can kind of parallelize this batch inference process, and we could try the 90B model. We could try OpenAI vendor APIs getting in the mix. And what that looks like from a code perspective is really not that different. We're just kind of using, in this case, like we're going to show a snippet of code briefly. I'll break away to. which shows this prompt models workflow having just like in Metaflow, it's called a for each, but it's just parallelizing the execution of actually like run the LLM.generate call. So if I go over to my GitHub tab here, in the repo that we'll share at the end of the presentation, you can see that the prompt models is just kind of normal Metaflow code. If you're unfamiliar with Metaflow, don't worry too much. It's like, just think of it as like machine learning DAG. If you are familiar with Metaflow, awesome, you're the bomb, and talk to us in Slack. But this workflow that does prompt models, it's exactly what we saw in the picture. It has a start step. This kind of just does some bookkeeping, understands, what was triggering me upstream. Like, was this, I got new photos, and then that triggered this workflow to run. And we can see here that we are batching over the different models. So we're going to run the batch through each of these different models. Here's the for each construct that I mentioned. And then for each of those models, we're going to do this prompt model function, which nothing terribly interesting. It's just pushing data through one of these vision language models. There's no training happening. This is pure inference. And then our response is we get the kind of link from the image to the prediction of what the tags should be for each of these models. What this ends up looking like is like whether you're at both inference time or whether you're in kind of training experimentation mode as a data scientist, there's models everywhere, as Buzz Lightyear says. We have custom models, we have vendor API models, we have different versions of the custom models, say from Meta's Llama team, different sizes of each model. So there's just models all over the place is the point. And like picking one is a losing game at the beginning of experimentation, or even after you're done running your experiments, as we saw in the case with Cursor. You don't want one model, you want a system of integrating these models into your products and machine learning workflows. Obviously, once you have multiple models, what this kind of makes reality is the evaluation component of your machine learning system becomes much more interesting, as you can have comparable evaluations across the different models. So if we bounce back to the code briefly, can see that this evals workflow has the same structure. Again, this isn't like a sales pitch for Metaflow per se, but Metaflow is a very good system for doing this. It's the one that I'm most accustomed to using. So in this case, we have the same flow spec concept is being subclassed by this evaluation flow. We have the same kind of structure where we have a start step, we have an evaluate step. And this thing is going to actually be looking at the outputs of that prompt model function and is going to be aggregating some measure of performance, essentially. The upshot of this is now here's a view of the Outerbounds UI, where the output of that evaluation workflow is going to be some custom evaluation component, say, where for each row now, this kind of maps, you can like conceptually think back to, like, let's actually just show it. You can think back to this slide where these are the different predictions happening. So we have this is like one inference example, like one kind of batch inference across these different models. This is going to happen for each data point. And then basically we compute the performance measure across all of those. In this case, we're doing like 10 examples. So the batch size is 10. And there's some recall measure that we get out of that, or could be some more exotic kind of evals thing that's more specific to our use case. But in this instance, just kind of vanilla recall is a very reasonable metric to start off with. So we can see like there's already some interesting things that we can observe in these evals just by like kind of having this system with no fine tuning, nothing fancy, no RAG, nothing. It's kind of curious that the 11B model of Llama 3.2 is better than the 90B one. So it's almost 10x cheaper to run that model on our own hardware, and it's performing better. It's also performing better than these OpenAI APIs in this specific use case. So that's kind of interesting. I mean, like, this is independent of any kind of prompt engineering or prompt optimization, but just in our vanilla case, off the shelf, the smaller open source model is doing better. So kind of pointing out, like, again, back to the idea, like, you don't want to just pick upfront some model to go with or some vendor to provide you with a model. You want to have a system that allows you to actually explore these different trade-offs and Pareto frontiers for each use case that matters to you. And over time, you're going to want to do this for within the same use case on different time intervals as well. The idea here is, like, we're going to have a little slide build. We're going to like take a little break from the actual use case and kind of get into concepts mode, as like what might be in your head if you're leading a data team or you're starting a new product and you're kind of the ML engineer that has to design a lot of these systems. What we've done so far is basically stress the importance of, you want to treat your data, your models, and your code, you want to treat these as assets, not just some like files in the cloud or something. These are like distinct components that are, that like it's important to connect them into some like value producing system from the onset, not just to start running, run inference a bunch of times and then just store a big pile of data somewhere. It makes sense to actually register both the data sets and the models somewhere, so that you can kind of have an organized way of analyzing what's doing well and what's not, what kind of data do we need to collect, maybe what other types of models might we want to try, things like this. Of course, the wisdom is like start with the simplest API that's reasonable for your use case. If you can't send data to a vendor API for security reasons, well, that's one thing. But if nobody cares about that, well, just start with like hitting OpenAI and hitting Claude and see what happens. Kind of that's always a good way to get started. And start the evals loop with these simple APIs that are easy to use just by grabbing an API key. Now from there, like what we showed is kind of this thing further to the right of trying lots of different models and then kind of starting to analyze the evals across these different permutations. The other thing in the middle that like a lot of people balk at fine tuning these days, like a lot of people think it's not worth it, it's too expensive, it's like got all these risks attached to it. Other people like Outerbounds is one company that does kind of provide infrastructure for fine tuning for many of our customers. But the thing that I want to stress here is that as you're building this kind of asset factory and you're treating your data sets as actual assets and not just some kind of throwaway resource that you pump through the models, the same exact data sets that you're going to eventually need to do fine tuning anyways, they already exist. You just have to curate them at the time that you're pushing data through these models, and whether it's batch inference or some agent graph or something like this. So this middle piece is not so much to say like you should always consider fine tuning or fine tuning is better than RAG or whatever thing. The point is that no matter what of those downstream methods you're going to try, curating the data sets as assets is the thing that enables you to do all of that anyways in an efficient way. And then of course, like if we end up wanting to fine tune, we can kind of increasingly customize the evals to track, like, is this model actually doing well? Is our learning curves of those fine tuning processes, are they actually correlated with doing better than one of the vendor APIs, for example? But connecting these things all in a system kind of starts with that foundational layer. We have to actually track these things like they're important, valuable items. Like kind of extending this narrative a little bit, like as we build these different components of an ML ops system or Gen AI ops system or whatever we call kind of the DevOps infrastructure, this thing that like starts with like you need computers and you need data and then you need to do something with that. Kind of no matter what, like the idea that I want to put forward here is that this like factory concepts that you're building as you move to the right here, and the ability to like connect resources like available GPUs, scalable data pipelines, things like this. This is what actually makes these models go from just being kind of like, you're just doing something that's like easily commoditized, kind of like building a business model that's probably easy for OpenAI or Anthropic or somebody to just replicate if they choose to. That's a very different thing than trying to build custom differentiated assets that connect to what's unique about your business, what's differentiated about your business. So, all right, now I said my whole spiel about like maybe you don't want to do fine tuning, but a lot of people do. A lot of people are asking us, like, how do you do fine tuning on Outerbounds? Other platforms have it as well. Bedrock has it on AWS, things like this. It's the same system. And as I was saying earlier, the same data that's coming out of the update photos workflow in our example, that same data can then be curated. In this case, we have a different workflow called prepare VLM data, which all it's doing is taking those same images we're already curating from the updated photos and then refactoring them so that they fit into the instruction tuning model, so that we can do fine tuning with that data set. And then we fine tune it. We just use a normal Hugging Face routine, kind of like 200 lines of Python code. I'm going to skip the data set curation flow and just go right to the LLM fine tuning. See, I'm already almost at the top of the hour and want to keep good time for Q&A. So in this workflow, we have fine-tune VLM. Again, we have a start step. We're kind of understanding what happened upstream. We're splitting our data set, treating this like a normal supervised learning problem. We're kind of using the same benefits that have always been the reason people gravitate towards Metaflow, things like packaging environments, in a reproducible way, building these environments very fast when you're running on Kubernetes pods, especially these kind of beefy pods that take a while to cold start, spin up with GPUs on them. And then we're just running like kind of any code that you might see on the internet in a Jupyter notebook, for example, or there's all these collab examples that the team at Hugging Face and open source community have produced. There's just so much excellent stuff. And here we're taking that Quen model. It's a 3B model. So remember, the best one we saw so far was an 11B model from the Llama 3.2 on our task. And we're going to try and fine tune this Quen model and see what can we do. And I ran this fine tuning last night, and it was like very, very, like I ran it for like 5 minutes, basically, this whole step ran. So like less than $1 essentially running on AWS to do this. So, I mean, like I obviously pitch fine tuning a lot, and I know there's a lot of people that say you should never do it. But at the same time, it's mind blowing to me that we've come to a place in 2025 where already you can run a serious fine tuning operation on essentially a commodity GPU in AWS for less than $1. This is actually like reasonable performance consideration already, where like I'm not trying to claim like this model is better than OpenAI per se, or like, oh, if we just kept going, we'll definitely get first on this leaderboard. Because like almost by definition, it's like, well, we could fine tune the Llama 3.2 model too, and then that's probably just going to stay better as long as we have good data and enough data. But the point is like with less than 10 minutes of fine tuning and like about $1 in AWS costs, we're getting this thing already to have comparable recall to like some of these OpenAI models. And this is just like a 3B off the shelf. It's like not even the newest generation of the Quen model. So there's like huge arbitrage here is kind of my points in basically just trying things and seeing like what is the cost, the Pareto frontier really of cost to do this stuff, especially cost at inference time, where like with these vendor APIs, you get charged by tokens. Like what is the Pareto frontier between those kind of costs and how good is the thing doing? If it costs, 1/1000th of the same amount as the biggest, baddest kind of model from Anthropic or OpenAI, but you get 90% of the performance in a lot of like practical kind of constrained data science use cases, that's better than, kind of the closest possible thing to AGI or whatever the frontier labs are pitching. Okay, one more technical piece, and then I'll close up so we can get to the Q&A. Also, like one of the most important things about this kind of like factory mindset is continuous integration. It's, kind of like continuously able to build the stuff, of course, but then you need to connect it into the systems that actually distribute those assets to end users into your product, or at least into your internal experimentation pipelines. So on Outerbounds, kind of the way this works is you can deploy apps as endpoints. The kind of cluster scaling works very similarly to how it works during training. It's kind of a Kubernetes cluster running on your account. But making sure that this primitive is in place where you can kind of take the outputs of some kind of custom fine tuning, and then you can actually run the inference and do like either a comparison like this, which was done through the batch inference process, or in this app deploy case, we're actually building endpoints so that we can serve the models on a real-time server. And then what it ends up looking like is you can kind of just interact with one of these URLs. So let me just show where that URL is coming from. But basically, I did all of this kind of R&D. I quickly hacked it out last night, some of the fine-tuning process, ran the thing, and I wanted to see like what can I do to deploy this model. So I deployed this Quen 2.5 app here. So this is our URL. Let me actually just grab that to make sure I have the correct one still. Do export VLM URL. Okay, and then this command, what we're running, this is just like a little Python client that wraps the OpenAI client. So VLM is the inference server. It makes an OpenAI API essentially for any model that we're using. So here we're prompting how to build a VLM, and this thing is running kind of in my AWS account. But the key thing for this like factory story that we're telling is that it's plugged into all that upstream fine-tuning activity. So now this API essentially is just directly comparable to what we're getting from OpenAI or Claude or whatever thing that we were hosting on Together AI earlier. Cool. So now we have kind of full systems view. We have this update photos thing that's getting new data on a regular cadence. This is then triggering this prompt models function, which is calling vendor APIs. It's calling models hosted by other inference providers, like Together AI, for example, is a great one. It's also able to call the models that we're hosting on Outerbounds, so in our own cloud account, whether we're doing that for security, privacy reasons, or for whatever other reason. And then we have this whole kind of fine-tuning system that's actually connected into this factory. And of course, the evals at the end is kind of the thing that makes any kind of AI or data science flywheel go. Last slide, I promise. We also want to be able to take this whole thing and treat it like proper software. So it's very important that you have a concept of like, yes, code has the concept of branching, but so do these different assets. If you're familiar with using like a system like Vercel, for example, Vercel makes it essentially as simple as making a commit and pushing it to GitHub to deploy a new copy of your website. If you want to have multiple versions or you're doing some dev work and you want to see how they look against the production-like thing, but it's not the actual one that is shown to end users, this becomes super important. And that's the kind of system that we help our customers build at Outerbounds. And it's kind of a critical aspect of this. Like all this stuff doesn't really matter if you can't treat it like proper software, is kind of the link into this LLM factory piece. So that's it. So I guess time for Q&A, Mark, without further ado.
Yes, I'm going to go right to the Q&A. Thank you for that amazing presentation, Eddie. I think it's I think what an incredible time to be alive, where we have so many simple utilities that we can use to build AI factories of almost any kind. And I think for just like for pennies or a few dollars, you can do some pretty incredible things with open source models and a few frameworks that you can just plug in together and get it to work. So really, really incredible.
Yeah, it's mind blowing. Absolutely.
Yeah. All right, so we have 3 questions. The first question comes from Anonymous, and it says, how do you get around truth data when you don't have labeled data to start with?
What was the first word? The truth data?
Yeah, it says, how do you get around truth data when you don't have labeled data to start with?
Good question. I mean, so you don't necessarily need labeled data to do post-training. There's methods like as popularized by the DeepSeek R1 project that many people in this chat have probably heard of. There's kind of this reinforcement learning approach to post-training these models, which I didn't talk about that at all here. But that's one way that you can kind of avoid the need to acquire like labeled data. The other thing I'd say, though, is that you actually don't need that much data. An amazing feature of these LLMs is how flexible they are, despite being huge models. It kind of breaks my intuition a little bit, how flexible they actually are. If you just have 100 or 200 good labeled examples, you can start doing this fine-tuning process. Like the one that I showed is like about 200 images with the tags from Unsplash. So yeah, I mean, there's ways to do it without labeled data. It's going to be better if you can get good labeled data. Is kind of my take there.
I always say when it comes to data, quality over everything.
Yeah, no doubt, no doubt.
All right, the next question says, how costly factory mode compared to regular mode?
Well, I guess regular mode could mean a lot of things. So if I'm just using like Jupyter notebooks and all I do is just like I pay Colab $10 a month for the pro plan or something, and that's fine for my use case, that's totally valid. Like there's a lot of data science projects where you can produce a ton of value and you never need it plugged into like a software enterprise system like I was kind of pitching here. So like drawing that boundary is like, I am not in a position to say any generalized rule about that. But you'll know when you need to graduate to a proper software system. Like if it's really like a business critical process, and like say like Netflix, like your use of Netflix depends very heavily on their machine learning systems not breaking. Well, you can't just run that in a Jupyter notebook and like hope it all goes well. So yeah, I mean, I'm not sure I'm really addressing the question per se, but the cost is like, it's going to be more expensive. I mean, that's kind of like by definition, you're like kind of investing big time in like a core business process if you adopt this approach. So if you don't need it, you don't need it. But when you do need it, it's like do it from the jump is often quite helpful. It would be my advice.
Yeah, I certainly agree with that. It all comes down to scale and cost. And I guess with these new models, you can certainly bang out a really great POC before you decide to go to a big, huge factory model today.
Right. The factory model, I'd say, really comes into play when it's like you need to connect it to like classical ML and data pipelines and data transformation pipelines, and you have multiple warehouses upstream, and there's all this kind of like complexity that emerges in business environments, especially. That's when this kind of mindset matters basically. But if you're like a researcher or you're just hacking on a side project, like don't do that. You don't need it until you need it.
Yeah, exactly. So the next question says, can you speak more to the core components of an LLM factory and how do they differ from a typical MLOps pipeline?
Ooh, I like that a lot.
Mhm.
I would love to just say they don't differ. It's all the same. But I fear that that marketing positioning would very much not work in 2025. So I think like a big part that's different about the Gen AI kind of LLM world, because like at the end of the day, it's still code, data, and models is like the thing that I pitched here. And that's not different. Like that's the same everywhere that has like data-driven software. Um, what's different is that these models are huge and they need a lot more beefy compute resources to run them yourself. If you don't go that route, then you need to use other people's APIs, so you don't control the model anymore. So like that's a very important difference from say just like trying to scale a random forest or something in AWS. Another piece is like a lot of these systems are asynchronous, meaning like the inference call to my random forest model for a given data point is like that always has the same latency, basically, very tight kind of error bars. For an LLM process, especially this like agent world that's emerging right now, I mean, who knows when the agent's going to finish its deep research project? Who knows like when the model is going to have the right uptime or when the server gets overloaded and you need the autoscaler to kick in. So you just have to think about these things more when you're designing the system to be, there's like a new class of errors, I would say, is the main difference.
Yeah, I agree. I think that the process, we learn in business that the process always remains the same. It's just a different pipeline and different tools.
Right.
And like, for example, I run Olama or LM Studio on my RTX 3060 with 12 gigs, and it's incredible. Absolutely nuts what you can do with open source models. So I always encourage people to start off local, small as possible as you can to get a good result, because when you scale up, it's going to be mind-blowing.
Yeah, definitely. It like introduces a nice discipline as well, and like you'll learn good stuff about your problem by starting small.
Yeah, start
At that
small and
level.
constrained. Yeah. Yeah.
Mhm.
So the next question is, on continuous iteration, what are the best practices for closing the loop between user feedback and model improvements in a live product?
Ah, that's a very rich question. Okay, so like one quick answer is if you haven't looked at like direct preference optimization, I think it's the most kind of like obvious thing to look at to understand what's happening. Okay, so like what you'll see in these kind of like DPO data sets is we have an instruction. So this is the thing that we're sending into the model. Like the same is like what I was just doing with fine tuning with no images, but whatever. With DPO, we have a chosen response and we have a rejected response. This is how the model learns. It's got like a little special loss function that like, this is the stuff that determines how to do back propagation on the PyTorch model or the LLM weights. But you can imagine like if you're used to using ChatGPT, you'll notice that sometimes it generates two responses side by side. And then it asks you to give a thumbs up, thumbs down, or like pick which one you like better.
I've seen
So you can imagine like how a data set like this kind of pops out of that kind of user experience is one like very direct way to see it. But then there's all like the reinforcement learning stuff I was talking about earlier. Like there's all sorts of like other ways that you can kind of like inject the preferences of your users and their feedback and what kind of instructions they want to send to LLM along these lines.
So I guess would you say then it's like a CI/CD pipeline for done by the end user?
Ooh, in a sense, yeah. I mean, like the end user is much more involved in the data curation process in Gen AI than like traditional ML, I would say. Now, in terms of like the CI/CD aspect of like when does the retraining happen and like what like logical thing triggers that? Maybe some products like the end user drives that. That would probably still be like a new use case for me to understand, though.
I guess it would involve a lot of trust too for that your end users are going to give you the best answer, the most optimal answer.
Yeah, right. There's there's a lot of like filtering and post processing even on that simple story that I just described from ChatGPT.
Okay, so we have a question here from Razi Shafi. Thanks a lot for a great presentation. I appreciate it if you could kindly briefly explain the orchestration part a bit. Sorry, briefly explain the orchestration part again in the code.
Totally. So in the code that I shared, we're using Metaflow as the orchestration engine. In Metaflow, you can think of as like, it was built originally at Netflix to be like very scalable data pipelines and like kind of like beefy cloud batch processing jobs. So essentially what I was kind of saying, like I went on a little riff about like, okay, this is a batch inference thing, but like don't get too hung up on like real time versus batch inference is like often like people like over engineer and like overthink about that distinction, is kind of my point of view. And like oftentimes like if you really like hold the feet to the fire of the business people giving you these requirements, like batch inference is fine. So like that's the way that we're structuring orchestration here, is like just normal MLOps pipeline basically, where it's just a graph, and it's like those graphs that I was drawing in Excalidraw is like each of those is a Python function that runs somewhere in the cloud. With agents and like a lot of the new stuff in LLMs, orchestration has been kind of like remolded to be like the process that like orchestrates all the different LLM calls and kind of the management of all those different, like which LLM is calling which other thing, which one's calling a Wikipedia search, this kind of stuff. So like the dynamics of those runtimes is like still very active R&D. There's like tons of open source and startup projects competing for that. You could also just use an older system like Metaflow and like readapt it to do kind of the same orchestration. So what I'd suggest is just kind of like look at the frameworks. It's like very interesting what all these frontier labs are putting out in that context. But it's kind of like everything with MLOps. Like just learn about the concepts and the actual principles of what's happening. And then whichever tool you pick, it's like it really doesn't matter at some point.
Yeah. Oh, great question. Thank you for that question, Razi. Last question. When you fine tune, are you using a specific model or are you using different models as in prompt models phase?
Ooh. In this example, I'm just using one model. I basically fixed it. I think that would be a great suggestion for kind of a next research wave, would be to consider fine tuning across other models, other model sizes. I mean, even the vendor APIs, OpenAI has their own API for fine tuning where that same exact data set could be reused again. Yeah, so specifically in this code that I'm sharing, in the QR code that I had up on the screen earlier, it's just one model that's getting fine tuned.
Just one model. So I guess it wouldn't be too hard to introduce either models of different sizes of the same type, or different models that feature different tokens that can do or respond to specific use cases, right? Like I like to say one model, one job.
Yeah, totally. Or like, and then like another way to think about it too is like, I mean, now since it's less than $1 to run one of these training jobs, like another way I'm thinking about it is like it's becoming feasible to basically study these LLMs in the way that the frontier labs do. Like they're not going to do a hyperparameter tuning on like the 1 trillion size ChatGPT. They're going to do it on like a 1 billion version of the same model architecture and kind of extrapolate those learnings up as they scale the model size. So you can kind of start thinking about that as well. Like maybe you have 10 models, but I'm just changing the learning rate for each of these Quen models that we fine-tuned. Doing a grid search is kind of more like regular scikit-learn activities kind of.